Welcome to today's explainer. If you've been keeping even half an eye on the industrial energy sector lately, you've probably noticed that the competition in the fuel cell and industrial battery market is just absolutely fierce. I mean, companies are basically in an all-out sprint to develop the next big breakthrough technology. But here's the thing. Behind all those flashy headlines and massive manufacturing plans announcements, there's actually a hidden, highly technical metric that quietly separates the long-term winners from the ultimate losers. So today we're going to decode the official industry standards to figure out exactly what that is. So it's really the multi-billion-dollar question, right? What is the secret metric that determines which battery technology actually wins the market? Well, we're going on a bit of a journey today to find out. We're going to dive into the Sustainability Accounting Standards Board framework, or SASB for short, to uncover this critical industry secret. We're going to look directly at the exact accounting metrics that major manufacturers are held to, and you'll see how these seemingly dry numbers on a balance sheet actually dictate the future of global energy. All right, let's jump straight into Section 1, the battery market battlefield. To really understand the stakes of this battlefield, we have to look at this quote straight from the SASB topic summary for fuel cells and industrial batteries. It says, both customer demand and regulatory requirements are driving innovation in energy-efficient products with lower environmental impacts and lower total cost of ownership. The absolute crucial point to take away here is that survival in this industry isn't just about making power anymore. It is strictly about making power efficiently. Honestly, if you can't lower the total cost of ownership for your customer while keeping the environmental regulators happy, your technology is pretty much dead in the water. Let's map this out on a timeline so you can see how this pressure has built up. Think back to the 2010s. Back then, the focus was largely just on early adoption and basic energy generation. But look at where we are now in the 2020s. We are in an era where strict environmental regulations and skyrocketing energy costs are absolutely forcing innovation. Customers literally cannot afford inefficient power. And as we look ahead toward the 2030s, the demand is shifting entirely toward high-capacity storage. That's what's going to enable the global integration of renewable energy grids. These relentless, compounding pressures have completely reshaped what the market demands from these companies. Which brings us to Section 2, the secret winning metric. Let's lift the curtain here. The answer we've been looking for is use phase product efficiency. Now, I know that sounds like a bit of an engineering buzzword, but it is the true commercial and sustainability driver that dictates market share in this space. Basically, it's the measure of how well a product actually performs its job when it's out in the field, working in the hands of the end user. Take a look at how the official SASB accounting standard categorizes these exact metrics. If you look closely at that third row down, right under product efficiency, you see a highly specific breakdown of exactly how companies have to report their performance. What's wild about this is that it turns a standard regulatory document into a literal treasure map for commercial success. If a company can optimize these specific metrics listed right here, they are going to dominate the market. For sure. So how do they track it? Let's get into Section 3, measuring energy and capacity. First up, we have specific energy. The SASB standard defines this as gravimetric energy density, which is essentially just the ratio of nominal energy to the product's mass, measured in watt-hours per kilogram. Now, this is the absolute bedrock of understanding a battery's average storage capacity. Because think about it, you want massive amounts of energy, obviously, but you can't exactly drag a 5-ton battery around with you. You need the absolute maximum power packed into the lightest package possible. Next, we have coulombic efficiency. This brilliantly illustrates how much usable energy you actually get to keep. It's the energy removed during discharge, divided by the energy you had to use during charging to restore that original capacity. Basically, how much usable juice do you actually get back out versus what you paid to put in? High coulombic efficiency means you aren't wasting your money and power just to charge the thing up. Now, for fuel cells, the metrics shift a little bit. Here, we're comparing electrical efficiency, which is the net electricity produced, against thermal efficiency, the net useful power output. Both of those are divided by the total fuel energy input. The absolutely crucial detail to note here is that both of these are measured using what's called lower heating values, or LHV. This ensures that the efficiency rating is totally unbiased, and you're getting a true apples-to-apples look at energy efficiency. And keep in mind, these efficiency standards aren't just for one weird niche product. The SASB framework applies to a massive, massive scope of technology types. For batteries alone, we're talking lead-based, nickel, lithium, and sodium-based. For fuel cells, it covers direct methanol, polymer electrolytes, solid oxide fuel cells, the whole shebang.
So whether we're talking about small portable units or massive stationary power plants, these metrics are the universal language of performance. Let's shift our focus from the lab back to the wallet. In Section 4, the total cost factor.
This brings us to a giant, incredibly important number in this industry, 20%. According to these strict accounting standards, 20% degradation is the magic threshold where the operating lifetime of these products officially ends. Once a battery or fuel cell loses 20% of its initial capability, well, the industry considers its useful life totally over.
But exactly how we track that 20% degradation threshold depends on the tech. For a fuel cell, lifetime is measured in operating hours until 20% net power degradation occurs. For a battery, it's measured in the number of charge and discharge cycles until 20% capacity degradation happens. This makes it crystal clear why hitting this 20% threshold later rather than sooner is a massive competitive advantage. If your battery can handle, say, 5,000 cycles before hitting that mark, and your competitor's battery hits it at just 3,000 cycles, you have just radically lowered the total cost of ownership for your buyer. That is a game changer.
So what happens when we scale this up? Let's look at Section 5, powering the renewable grid. The SASB source text lays out the big picture perfectly with this visionary quote. It says, advances in battery technology to increase storage capabilities and improve charging efficiencies are critical for the integration of renewable energy technologies into the grid. Because look, wind and solar power are completely intermittent. The wind doesn't always blow, and the sun definitely doesn't always shine. We absolutely 100% rely on these highly efficient batteries to store that energy when we have it and deploy it later without massive waste. So here's how all these pieces build into a logical path to a sustainable future. Step 1, manufacturers have to maximize their coulombic and electrical efficiency. Simple enough. Step 2, by doing that, they successfully delay that crucial 20% degradation threshold we just talked about. Step 3, that extended life directly lowers the total cost of ownership for the buyer. And finally, Step 4, that resulting financial viability is what actually allows us to successfully integrate renewable energy into the global grid at scale. So this isn't just about fighting for market share anymore, it's literally about building a viable green grid for the entire planet. And that brings us to the ultimate question we are left to think about today. As global regulations tighten and energy demand surges, which manufacturers are going to innovate fast enough to conquer that 20% degradation threshold, maximize their use phase efficiency, and ultimately power a renewable future? The rulebook has been written, the metrics are set in stone, and the race is officially on. Thank you so much for joining me on this explainer today. And hey, keep your eye on those efficiency numbers.